first few weeks broken down. We're going to talk about the syllabus here in a minute. So that's what the yellow sheets are in the back, are the syllabus for the 256A part of the course, okay? So this week in lab, you're going to be doing experiment 18. In a little bit, I'll talk about the pre-lab for experiment 18, but you want to come to lab this week with the pre-lab for experiment 18 already completed, okay? So it's going to be checked before you can start experiment 18. So make sure you've got that ready to go in your notebook. If you have a notebook from last semester that you started at the end of last semester and it has less than 20 pages in it, you can use that. Otherwise, you need to get a new notebook too, okay? And the manual is the same manual that you had from first semester. Next week, we will start a 2-week experiment, experiment 17. So just to throw you off, we're not going to run completely in chronological order. Experiment 17, we're going to do the first part of that experiment, but you need the pre-lab for the whole experiment. So have that pre-lab all ready to go for next week. We will not have a quiz this week, but we will have a quiz next week. So be ready to go for a quiz over the first part of experiment 17, okay? Then in 2 weeks, we will finish experiment 17. We'll have quiz number 2. But experiments 16 and 18 will be due. So since it's a half semester class, we go quickly, fast, furiously as far as things being handed in and turned in and gotten back, received, or you receiving them back again. But just be prepared, your first assignments are already due 2 weeks from your lab period this week, okay? Experiment 16 is mostly an on your own assignment. It's just worksheets in the back of experiment 16. So you can start working on that at any point. I'll talk about it briefly at the end of lab lecture next week, but I won't spend a whole lot of time on it. So for the most part, it's just something you do. It has to do with NMR. It's something you're going to do on your own. When you need to use tables for that experiment, you're going to use the tables that are in experiment 16. But you could, today go ahead and start working on it. Okay, that'll be due in 2 weeks. Experiment 18, we're going to have to do the experiment, and you'll have to go through the process before you can actually start working on that. Okay, so heads up, a couple weeks, we already have things due. So a couple other high points of the syllabus. We've got who's teaching what at the top. You need to have met the prerequisites for the course, so make sure you read that information and have met those prerequisites. We will be having lab lecture every Monday in here. And the big guy is Monday, February 27th. Instead of a final exam, we have a midterm exam. And so at 4 o'clock on that Monday, we will all get together in here and take that midterm exam, which is the start of the week, kind of ending the first half of the semester and starting the second half of the semester for people doing the independent project. So just make sure you've got this date on your calendar to be able to be in here to take that exam, okay? The breakdown of experiments and due dates is on the next page. So here, the 24th and the 26th, I've already talked about for experiment 16 and 18 being due. A couple things to keep in mind. There's going to be some mini reports that we do for experiment 20 that are due before you even have experiment 17 due, so keep track of dates. But the reason for this, we'll explain this when we get to this point, is that experiment is a 3-week experiment. We need to, during the first 2 weeks, be checking your product and the data you have for your product to make sure you can keep going on to the next week. So that's why these things are going to be thrown in here in amongst with your experiment 7 being due, okay? So just keep in mind there's a little bit of not complete chronological order with due dates, and we'll talk about them when we get to that point. Here's the point breakdown, 375 points for the semester, so 250 points for the notebook. The midterm exam, since it's a midterm exam, is 50 points. Weekly quizzes, we'll have 5 of them. but we won't drop any this semester. Okay, so all 5 of them count because we do only have 5 of them. All right. And then there's 25 points for safety and technique. Okay, so that is the breakdown. We'll talk a little bit more about the details of the syllabus in lab this week as well. Okay. So this week we are going to be starting experiment 18. Experiment 18 is a lot like experiment 6. All right. So we have a flow chart that is not the same as experiment 6, but it is very similar. All right. I thought I was going to get away with the screen. Yeah, but not quite yet. Okay. So there's a few differences to experiment 6 and experiment 18 in what information you're going to be collecting. Okay. First of all, the unknowns that you're going to be identifying are, we've got more complex functional groups that we're going to be looking at. Okay. And so with that, there's more complexity in the analysis that you're going to do and more complexity in what type of hazards and so forth are involved with the unknowns. So very first thing, since you don't know what these compounds are when you receive them this week, make sure you wear gloves in handling them and keep them in your hood at all times. A lot of them have some sort of odor associated with them as well. Okay? So what you're going to be looking at with experiment 18 is you are going to use solubility tests to help you identify that unknown. So these are going to be very similar to the solubility tests that you did with experiment 6. I'll talk about some of the differences here in a little bit. You are going to do the Beilstein flame test. So you could possibly have a halogen. So you need to do, everybody should do that test. You're going to need to do other chemical tests, and we'll go through those here in a little bit. So that's mainly what our flow chart is looking at. And then we need a lot of, you're going to use more spectroscopy than you've used in the past, okay? So first of all, you'll use your friend, the IR, and collect an IR spectrum. You will also make a GCMS sample, and the key to this is you want the mass spec, okay? So you'll get a mass spec for your unknown. And then you are also going to collect the proton NMR. I'll talk about these, the sample prep for these here in a little bit. This information will not be immediately available to you because it's samples that we have to run for you. But the rest of this you will be doing in lab and getting that data for before you leave this week, okay? One more piece of information that you're going to get is CHN, or the elemental analysis. And so you will get that this week for your compound. And that is something you won't collect. You'll just be given a piece of paper that tells you that. And so we're going to go through some examples of how to use that information. Okay? So one thing that's not on here, or a couple things, there's no collect a boiling point or collect a melting point, right? So we don't want you doing that, okay? We want you to be able to identify these unknowns based on the information you have from the tests, and then based on all of the spectroscopy and all that data that you are going to collect, okay? So don't collect a melting point, don't collect a boiling point if you have a liquid, or a melting point if you have a solid, okay? You're not going to be using the tables in the back of your book to figure out what these unknowns are. So that's the one difference from experiment 6 versus this experiment. You're going to put together all the pieces that you collect, and then using the pieces of the puzzle, figure out what you've got, okay, and what unknown you've got. Now, one thing you will collect is for all of these guys, you will get literature data. So you will, once you've figured out what your unknown is, you will go and compare what you think your unknown is to the actual literature, okay? But this is a very last step, so you will be collecting the literature data, all right? Okay, so let's look at what compounds you're going to be using or looking at. Our technology is waking up. So we're going to have a lot of oxygen-containing functional groups that are possibly going to be in your unknown. So it could possibly be an alcohol, a phenol, an ether aldehyde, ketone, carboxylic acid, or an ester, all right? And so the flow chart that is in your lab manual, this flow chart is for those oxygen-containing compounds, all right? So if it contains oxygen, you're going to use this to figure out what your unknown is, okay? And so when you get your CHN analysis, kind of a key here is if you have a nitrogen, you're told you have a nitrogen, okay? If you don't have a nitrogen, you're gonna have to follow this flow chart, okay? So either there's a nitrogen present or there's not. And so that's the first decision you're going to make here. Is there a nitrogen present? No, then I'm going to work through this flow chart. If there is a nitrogen present, then I'm going to work through the test for nitrogen. Right? Then for the nitrogen-containing compounds, it could possibly be an amine, an amide, a nitrile, or a nitro compound. Okay? And all of this is in the front. This isn't new information that you don't have. This is all in the front of Experiment 18 in your lab manual. One note is there, with the nitrogen-containing compounds, it is possible to have more than one of those. Okay? The oxygen-containing functional groups, you will only have one. All right? But there are also some secondary functional groups, and that's where the Beilstein flame test comes in. Okay? So you could have a halogen. That is a secondary functional group to these main functional groups that you're looking for. So that's why you're going to do the flame test. You could also have a double bond or a triple bond in your compound. So if you have one of those, or how would you test to know if you have one of those or not? Remember from first semester? Potassium permanganate and which other test? Oh, it's just faded so far away. Bromine test, yes. So potassium permanganate and the bromine test. You need to do both of them, okay? Not just one of them, both of them. The functional groups, the other functional groups you're looking at can potentially react with the potassium permanganate or with the bromine. So you have to do both tests and get a positive before you can say that it's potentially a double bond or a triple bond carbon in your compound, okay? The other, and actually one note with that, remember with the bromine test too, like if you use 20, 25 drops and it's still staying clear, that's a pretty good indication that that's a positive result for that test, okay? So don't drain all the bromine to the point where you get, finally it's a state orange, because that could take a really long time. If you get up into the 20, 25 drops of bromine, you're good, all right? The other secondary functional group you could have is an aromatic ring, okay? We don't have tests for the aromatic ring, well, we don't have chemical tests that you're going to use for the aromatic rings. But once you get your spectroscopic data, you're going to have a lot of information about whether there's an aromatic ring or not, specifically when you look at the NMR, but also the IR and the mass spec can tell you that, okay? So just keep in mind, you're testing for these two groups, but this could also be a possibility that you find out once you get all your data is in there, all right? So what I'm going to do first of all is let's go, and so here's all our possible other compounds. I'm going to go through the tests for the different compounds so you can see kind of what you're looking for, because there's a lot of different things that we're doing this time around. It's not just 4 tests like we did with experiment 6, all right? And thankfully, I was on sabbatical last semester, and Dr. Johnson put all these slides together with all of the confirmation tests, so I didn't have to, I just stole slides. So anyway, so that was one benefit of being on sabbatical. Let someone else come in and take their own spin on it. The one chemical test that you would do for a nitrogen-containing compound to determine if it's an amine or not is the copper sulfate test. And what you will get is a complexation reaction with the amine, and you get this blue or kind of teal blue-green solid that forms. Okay, so you're looking for the formation, like copper sulfate, if you remember from Gen Chem, is like teal blue-green, okay? So just it being blue-green itself is not a positive result. You're looking for this blue-green color change or formation of a solid, and then that's most likely an indication that you've reacted with an amine. The other thing with the nitrogen-containing compounds is they're going to give you some information about what solubility tests you should get specific results with. For example, with amines, if you put an amine in water, it should actually give you a basic solution, okay? What you don't want to do with any of the nitrogen-containing compounds is do the sulfuric acid test. That could be a very powerful reactive situation that you don't want to get involved in, okay? So no sulfuric acid solubility test with the nitrogen-containing compounds, all right? And so we've got this information, you've got the other solubility tests, and then you're going to use your spectroscopic data and your CHN analysis. From first semester, our DNP test, now first semester we were just looking at ketones. This test actually, you get a positive result for ketones or an aldehyde, okay? So this is the first test you would do on the flow chart to determine whether you have a ketone or an aldehyde. If you get a positive result, so you get like this orange solution turns kind of yellow-orange and a nice yellow-orange or bright red-orange precipitate forms, that indicates that you have a ketone or an aldehyde, but it doesn't tell you which one, okay? So the next test that you would do is the chromic acid test, okay? And if you have an aldehyde, it'll react quickly. If you have a ketone, it will either very slowly react, or you won't see any reaction at all, okay? So we're talking a minute or two for the reaction of the aldehyde, more than that time for a ketone, or not at all. Now the chromic acid, you need 1 drop of it, but you've got to be really careful with it. It's very reactive with a lot of things, and we don't want to get any contamination with any organic compounds in it. You also don't want to get it on you, so make sure you wear gloves when you're handling the chromic acid. Like I said, you should wear gloves throughout the experiment, but definitely be really careful with the chromic acid. It's stored in a beaker by itself at the back of the hood, so it's not intermingling with other things. You'll use 1 drop in a solution of your unknown and acetone. If in a minute you get a blue-green, or a couple minutes you get a blue-green solution, or even sometimes you get a little bit of solid forming, So here's the reagent that's more red, reddish orange. You get this bluish, greenish color. Then it's a presence of an aldehyde. If you don't get any result, or it takes a really long time, then most likely it is a ketone. So what you need to do, though, is be careful, because all alcohols and phenols can give a false positive. So you've got to make sure your DMP test is conclusive and you have good results from that before you go on to do this test. Otherwise, you will kind of mess yourself up along the way. Okay. So be careful, because since ketones react, make sure you don't have any acetone contamination. Okay, because that's going to be a problem for these series of tests, especially the DMP test. Okay. If at the DMP test you get a negative, so we're not going down this path anymore, then we're going to go on and do the ferric chloride test. What you are doing in that test is you're looking to see if you have a phenol or not. We have to do this test before we do ceric ammonium nitrate, because we need to rule out whether or not you have a phenol. If we do ceric ammonium nitrate first, that won't help you decide anything other than there's an OH in there. Okay? So ferric chloride will only react with phenols. Ceric ammonium nitrate will react with any alcohol, including phenols. Okay? So we're going to do the ferric chloride test first, and basically what happens is we get this complexation reaction with the ferric chloride. And so you can form this iron complex. The reagent, the iron chloride, is kind of yellow or even yellow-orange, and the positive test result is it's kind of a red or reddish purple, or kind of can be a reddish blue, but it'll be a distinct color change if you do have a phenol, okay? If you don't get a positive for the ferric chloride, then you're going to go on and do the ceric ammonium nitrate test. So this, again, is one you've seen before. We have the complexation of the ceric ammonium nitrate with the alcohol in the reaction. So we've got yellow ceric ammonium nitrate. We form this orange-red solution if we have an alcohol. So we go from yellow to orange-red, okay? Just keep straight where you're supposed to use, depending on the solubility of the alcohol, whether you're supposed to use THF or water for the test, okay? Because it depends on what water solubility you have as to whether you use water or you use THF. So follow the directions for this one really carefully, okay? If you get a negative for ceric ammonium nitrate, so if we got a positive for ferric chloride, we're done. If we got a positive for ceric ammonium nitrate, we're done. If we get a negative all the way through, we're going to go on and do the hydroxylated test for esters. This test is a multiple step test, and it's there's a lot of steps involved. So you have to make sure you're following the directions very carefully, okay? You're going to react with ammonia, this hydroxamate, and then you're going to go on, hydroxylamine, and then you're going to go on and add sodium hydroxide to it and ethanol, and you add heat to it. And so there's a whole lot that's involved in the test itself, all right? What you get out of it, if you have a positive result, is you get this hydroxamic acid, that then the very last step you add ferric chloride to it, and you get this complex that turns color. So you don't see any color change till the very end when you add the ferric chloride. So everything's going to look pretty clear and mostly colorless up to that point. Then we get our purple complex, okay? So there's multiple things you're going to throw in here of varying different colors, but in the end, if it's positive for an ester, you will get this purple result when you, very last step, add your ferric chloride. Okay. So, like it says here, it first converted to hydroxamic acid, and it's still colorless, and then you produce the purple complex. All right. If you get to the end of this flow chart, the last thing, so if you are negative for an ester, okay, the last thing you would do is test for the solubility in sodium hydroxide, and that'll be taken care of during the solubility test. If it is, your compound is not soluble in sodium hydroxide, then if it were soluble, it'd be a carboxylic acid. If it's not, then you possibly have an ether. So like in experiment 6, the functional group that wouldn't test positive for anything was an alkane. The thing that won't test positive for anything is the ether. So you get all the way through this, the ether is the guy that you are suspecting at the end of going through the flow chart. Okay? So it is possible that you will have to get through all of this to then determine if you have the ether or not. All right? So here's your solubility test. There's also a few times that it mentions, so read carefully the sections depending on, after you determine nitrogen or oxygen, read carefully through the different groups because there are a few of them that they will have you test also in 5% sodium bicarbonate. Okay? So here's the general ones from experiment 6. Remember, concentrated sulfuric acid is not going to happen if you have a nitrogen. The rest of these can, and then you potentially will also be looking at sodium bicarbonate. Okay? And then here's a reminder for the Beilstein flame test. You're looking for the green flame. Yes?
Would carboxylic acid not react to the can test with the OH group?
Yeah, because it's not just an alcohol, it's an acid group, so it's not going to react with the can test. All right. So now let's look at, so there's basically the rundown of solubility and the chemical tests. A couple other things to consider. So we've talked about all these guys. You guys now have collected multiple IR spectra, so you should be good. Like, just go ahead at whatever point you are ready to go collect your IR spectrum of your unknown, go ahead and collect it. Couple notes for GCMS and NMR. For GCMS, for the samples, you're going to use the same GC vials that you use for experiment 8, 11, and 14. Okay, so it's those same little vials. If you have a liquid, you are going to put 1 drop of that liquid and no more. Okay, so 1 drop of the liquid. And then you're going to fill to the neck of the vial with, this time we're using dichloromethane. The main reason for that is we've got more complex solubilities, okay? So it's just like preparing a GC sample, except for you're using dichloromethane as your solvent, and it's going to be your GCMS sample. So you'll still then label the vial carefully, put it in the little holder, fill out the sheet, because we're using the sheet to enter your data, all of that, all like last semester, okay? So liquid, 1 drop in a vial. For a solid, you want to use about 5 milligrams, not very much at all. And then the same instructions. You want to make sure, so still filling it up with dichloromethane. Make sure in that vial that you then, once you have the solid, you've shaken the vial pretty good to make sure that the solid is actually dissolved, okay? So just like with the regular GC, we cannot have any floating solids in your GCMS sample. If there's any floating solids, you're going to have to remake the sample, okay? So make sure no water has gotten in there, make sure no solid has gotten in there. If you have GC vials in your drawer when you go to check into your drawer this week, don't use those, just use a clean vial. We don't want to question what contaminants could be in there and you're trying to identify unknowns that don't make sense, okay? NMR has has similar instructions, and this is for proton NMR. So when you get to independent projects, if you're looking at other nuclei, how you prep your sample may be slightly different. You're going to have 1 drop in the NMR tube, so we're going to hand out NMR tubes to you this week, and it'll be yours for the duration of this semester, either for half of the semester or the whole semester, so be careful with it, because they're very fragile, okay? And you're going to fill to about 5 centimeters is what you're aiming for, so it's a height of the solvent. That helps with when we're running multiple samples in the same solvent, so we're going to put all your samples on together for one class period. It helps if the solvent height is the same. You want about 5 centimeters of deuterated chloroform, okay? So make sure it's not dichloromethane. We've got both of the sample prep area has both options available, okay? You have to use the deuterated chloroform for prepping your NMR sample. If you don't have a deuterated solvent, we can't run your NMR sample, okay? If we can't lock on your sample, most likely that's because it's got dichloromethane in it instead of chloroform, deuterated chloroform, so be careful. This bottle has a green cap on it, okay? So look for the bottle with the green cap for the NMR sample. For the solid, again, it's about 5 milligrams in about 5 centimeters of deuterated chloroform. We can help you get that solid in there. We can kind of use a pipette as a capillary and help get the right amount of solid in there. So for prepping your NMR sample, if you end up with a solid unknown, just talk to your instructor or your TA. We'll help you get that sample prepped for you, okay? These 2 things need to happen before you leave lab this week. We need these samples prepped right away, so then we can run the samples for you and you can get the data back. You potentially could have your GCMS data back before next week. Your NMR data, we're actually going to teach you how to process that NMR data next week in lab. And so when you leave lab next week, you'll leave with your NMR spectrum for your unknown. Okay? All right, questions with that? So I basically covered all these guys except for the elemental analysis. So that's the last thing we're going to look at here. So I'm basically going to go through the information that's in your lab manual for the different examples and different types of elemental analysis that you're looking at, okay? So it's basically, with elemental analysis, you're basically looking at kind of the math problem with knowing your molecular weight, all right? Let me wait towards this line here. All right, so the first example in your lab manual, you get your slip of paper with your unknown number on it, and it tells you, so that slip of paper is just going to tell you a percentage of either and or carbon, hydrogen, nitrogen, okay? That's all that's going to be on there. So if you don't have nitrogen, it's just going to be carbon and hydrogen, and you have to figure out the other pieces. So that's why we're going to go through these examples. So say you get your slip of paper, it's got 77.4% carbon, 7.6% hydrogen, and 15% nitrogen, okay? So the first thing you want to look at to see if there's anything missing is, does those percentages add up to 100%, all right? In this case, they do. So all that you have in that compound is carbon, hydrogen, and nitrogen, all right? The other piece of information that you are going to get is the molecular weight, because you're going to have your GCMS, okay? So you're getting that, your M+ peak from your GCMS, which is going to give you your molecular weight information, okay? So what you do with this information, once you've figured out if it's 100% or not, and what are the other pieces missing, and the molecular weight, is you go through, and for each element, you're going to multiply the percentage as a decimal times the molecular weight, and you'll get a number, okay? Then you take that number, so in this case for the carbon, it's 0.774 times 93 is the M plus peak equals 72.1. We'll take that number, 72.1, and divide it by the molecular weight of carbon, okay? And we get 6. So then we do the same thing for hydrogen. It was 7.6%, so 0.076 times 93 gives us 7.08. We take 7.08 divided by the molecular weight of hydrogen is 7. And then nitrogen, 0.15 times 93 is 14. And molecular weight is 14. So 14 divided by 14 is 1. Okay. So then what this tells you is our coefficients for the formula of your compound. Okay. And so the molecular formula is C6H7N. All right? So then you have your molecular formula. And so that's what you want to leave the calculations for elemental analysis with, is you eventually want to have the molecular formula. So then once you have the molecular formula and you have all your other information that you're collecting, you can put the pieces of the puzzle together to figure out what compound you're looking at. All right? So sample 2 is a little bit more complicated. All you are given is that it's 70.5% carbon and 13.8% hydrogen. Okay? So that doesn't add up to 100%. So you're missing some sort of information. All right? If you have nitrogen, you'll be told you have nitrogen. So it's not that we just got tricky on you and decided not to tell you you have nitrogen. Okay? So that's not its missing component. So we're missing 15.7%, and the flame test was negative, so it's not a halogen. So if it's not a halogen, the other possible suspect in this case would be oxygen. And with CHN analysis, you don't get, like in real life, if you submit a sample for CHN analysis, elemental analysis, you don't get percentage of oxygen because you get this information by basically combusting the compound, burning the compound. Well, you can't calculate oxygen because you're using oxygen to burn the compound. Okay? So that's why you don't get oxygen from that analysis. So we've got 15.7%. It's not a halogen. It has to be an oxygen is involved. So let's use our math. We go 70.5% times and our M plus peak is 102. 0.705% times 102 is 71.9. Divide that by 12.01, we got 5.98. The hydrogen, 0.138 times 102 equals 14.1. 14.1 divided by 1.008 is 14. And then oxygen, 0.157, so that's what was remaining, times 102 is 16. Take 16 divided by molecular weight of oxygen, 16 is 1, okay? So this 5.98 is pretty close to 6. So we can say that our molecular formula is C6H14O. Okay? All right. Now let's look at a couple of them where you have to take the information you have about halogens. Okay. So if you have a halogen, your flame test hopefully won't fail you. What other information will you have about a halogen in all that information that you're collecting? Where will you be able to get more information about halogens?
Mass spec.
The mass spec, right? So what you've got to recall from first semester lecture is your isotope patterns, okay? And how you can use those isotope patterns to figure out how many, not only which one, but how many of a halogen you have, okay? So refresh your memory on those guys, okay? So this guy here, we've got 60.64% is carbon, 4.5% is hydrogen. We don't have any other information. The percentages don't add up to 100%, and 31.5% is not accounted for. But the Beilstein flame test said it was positive for a halogen. Okay? So now you got to look at your mass spec and see if you can see any fragmentation patterns that point to a halogen. In this case, it had a pattern that was consistent for one chlorine being present, and the M plus peak was 112. So therefore, one chlorine would be 31.5%, which would be that extra missing piece that we're missing from our 100%. Okay? So we go through the calculations again for carbon, for hydrogen, and then the calculation for chlorine, and we get basically 651 as our ratio, and so you get carbon 6, hydrogen 5, and then 1 chlorine. Okay? So does everyone see how to use that halogen information? Yeah.
So you know that oxygen is not present?
The reason that you knew oxygen wasn't present is because once you accounted for the chlorine, knowing your M plus peak, knowing you have one chlorine and the M plus peak, what percentage of that 112 would be the chlorine? That gets you back to the 31.5% that would be one chlorine is that missing, what you were missing from the 100%. So that's how you knew you didn't have an oxygen present. Okay. Now for this case, so this is how you can see the difference between halogen present without an oxygen, and then I'm going to show you one where we've got oxygen. You're not, this is kind of an anomaly situation here, example, because you're not going to have one that doesn't have an oxygen or a nitrogen. You're going to have one of those, okay? But this is just kind of the baby step into the next problem, okay? So then the next problem, we've got the elemental analysis is 53.7% carbon, 3.2% hydrogen. Percentages don't add up to 100%. We've got 43.1% not accounted for. The flame test was positive for a halogen, and it was a chlorine. And our M plus peak is 156. So that one chlorine is going to be 22.7%. That doesn't take into account all of the 43.1%, okay? So we're missing 20.4% from that information. That's where you're going to then be pointing at an oxygen, okay? So if you've got your carbon, you've got your hydrogen accounted for, you've got your halogen accounted for, there's no nitrogen, you're still missing some element there to help you get to 100%, it is going to be the oxygen in that case, okay? And so then, if you take those percentages, we end up calculating about 7 carbons, 5 hydrogens. The oxygen was 20.4%, so times 156 is 31.8, divided by 16 is about 2. And then our chlorine, we knew from the mass spec, was 1. So then the formula we come up with is C7H5O2Cl. Okay. Everyone see what you're going to get out of this? Okay. Yes?
For the mass spec, when we did 2 chlorine, we have 2 of those 3-to-1 ratio peaks, so like how can we...
Well, remember with mass spec, what is it that you see 2, or what happens with?
Well, you have like a set that has like a 3-to-1, so like there's kind of seen as like the different isotopes of chlorine. So then...
But are they additive?
Like I know that's like 1 chlorine, right?
Right, that's 1 chlorine.
So if you would have 2 chlorines, that's how that would be different.
So,
You lose one.
what do
and
you
then
guys
lose the other.
recall from mass spec? If you have more than 1 halogen. No one recalls anything from mass spec. You're gonna see the additive. Right, you're gonna see the additive from your isotopes. So review your McMurray and your mass spec information. Okay, and how you can tell the difference between chlorine, bromine, and iodine. Okay. So, okay, hang on a second. I'm not done yet. So, experiment 18. You have a report form to turn in, and actually I've kind of amended from what's in your lab manual, so I'm gonna try and make copies for you guys of the new report form. So don't fill in the report form like the instant you get to lab this week. I'm gonna get copies made of this guy, and then I'll get you new copies for your report forms, okay? So, top part is very similar to experiment 6. Give the structure of your unknown, give the unknown number, give what the name of it is, make sure you've got section number, your name on there. Okay, so the results from the elemental analysis, you want to give the results and show the math that you used to get there, okay? Show how you calculated that elemental analysis, all right? Then you're going to give the summary, and so then that conclusion is what is your formula for your compound, okay? For the solubility test, you can just give a table for the solubility tests. So give, the solvents, what was soluble, what was insoluble. If you have anything that's kind of iffy, make sure you note that. And then what conclusions you get out of your solubility tests about your unknown? What are the possible functional groups, okay? Then you go on to your chemical tests and figure out what functional groups you're looking at. Probably somewhere in here it'd be a good idea to collect an IR spectrum, because your chemical test should reflect what's going on with your IR spectrum too, okay? So list all the tests that were done, including our extra ones. Our flame test, our bromine test, our permanganate test. List them, list the observation, and then what does that mean? So don't just give, bromine test, positive, that's it. Like, give the bromine test colorless even after adding 25 drops, hence it's a positive bromine test, and what that means potentially about your carbon-carbon or your triple bond. Okay, next page. So there's 2 pages. You guys are just so excited. Okay, what does the unknown look like? Physical properties, physical description of your unknown. And then list what possible compounds that you can consider, okay? You already have information about what you should use for an IR table. It's the same IR table that we used last semester, okay? So refresh your memory, at the end of experiment 5, there's an example IR table. NMR, we will most likely, like in lab this week, we will give you kind of everybody kind of has their own little take on what they want for an NMR table. So I'm going to let your professors tell you what they want for an NMR table, okay? But you're going to need an IR table, you're going to need an NMR table, you're going to need to follow these instructions. You're also going to need to make notes and identify things with your mass spec, okay? So make sure you read through these and make sure you've taken care of all of these, okay? You will also, like I said, need a literature IR, literature mass spec, literature NMR. A good place to get a list of resources for all of these is with, at the end of experiment 16, there's a list of what the website is for SDBS, or just Google SDBS. Aldrich Spectral Viewer is available anywhere where the clone computers are, so the Duck Lab, 3101, Dorm Computer Labs. There's also a NIST website that's listed there that you can use, which is a good one for mass spec information, okay? So look at experiment 16, that'll give you more information for what resources to use to figure out the literature for your unknown, okay? Remember with the IRs too, don't use vapor IRs because you're collecting them neat, either as a solid or not vapor.